broadcast.
Because it takes a few minutes. Okay, go. Stop talking.
Hello everyone. Welcome to the first hardware training session. This is going to be the first in a series of 3 hardware training sessions. I hope you have plans to join the rest, but this will be the first one, and we'll be covering like sort of the basics of and like introduction into like sort of over the season a little bit, what you can expect to be doing at what different stages, and a bit of an introduction into sort of the kit of parts and some of the systems that you will be building. I'll just wait a little bit longer for some more people to join.
Tell people to introduce themselves by typing their names in the chat.
Coding is like
Okay, I think I'm going to just head over to the next slide to get started a bit. So, I am Ethan Buckle. I am one of the organizers of Ignite. I'm currently the co-captain of TextBand, and I'm the mechanical lead as well as the systems integrator on the team. So our team is based in Cape Town, South Africa. It's been going for 4 years now. I think this is like our 5th season. I myself have been in FIRST for 6 years, 1 year in Lego Robotics, and then 5 in First Tech Challenge, of which 4 have been with this team and 1 with a different team. So, to get started with the season, basically in September, I think you've heard in some of the general training sessions that you get released a new game sort of every season, and that's going to have new challenges that you're going to have to solve, new game elements, new layout for the field. That's all gets released on September 7th. And that's sort of when you start to think, oh wow, this is such a big challenge, there's so many things to do. And with your kit, that's when you're going to start like putting it together, here sort of what the starter robot is going to look like for that season, and really start putting it together. So you've got about 7 to 8 weeks to do that, to get familiar with all of the different parts before the first like practice competition. We call it a scrimmage. It's sort of an informal but also a formal event. So we'll probably have the first one about sometime in November, and that's a really good place to connect with other teams, see what they're doing. They'll probably have different ways of picking up different elements or driving even than what's done with the starter robot. And you'll after that sort of probably see, wow, we could improve this thing on the robot, or we could improve this. And with those ideas, I think it's maybe a bit overwhelming to see the different ways people do things, but we really advise that you, up until that point, just stick to the starter kit, get familiar with sort of the different things that the different parts in the kit, and then after that point, after the scrimmage, after you've actually played some games, learned a little bit of how things work at an actual competition, working with other teams, then you choose one thing to really focus on and improve, so that by the time you get to regionals, that's about a month or two later, depending on when it is in January, you'll have something that you've improved. You've got some of your own designs, maybe your own parts made out of other different materials, just so that you're more prepared for the regionals. You'll have a bit of practice from the scrimmages, and then about a month after that, we've got the national competition. So if you do well at regionals, you'll get an invite to get over to Nationals where you'll have further competition with really good teams. Some of the best teams in the country even. So, this is basically what you will get in the starter kit. So you can see it's a lot of parts, but a lot of parts are required to build a robot. So you can see we've got, if you can see my cursor, you can see we've got mouse. Well, yeah, we've got some motors up in the top left-hand corner. We've got a battery. We've got a charger, some gears, some other parts, and with the starter kit, you've really got everything you need to build that starter robot, and you'll be getting familiar with all of these parts, even if they look a little bit foreign to you at the moment. I assure you, by the time you've spent maybe even like an hour or two with them, you'll probably know what most of them are for and be able to use them quite well, especially after you have finished like following instructions on how to build the starter robot. But getting onto that might be a bit overwhelming to build a robot, but there are lots of resources online. There's some video tutorials on how to put different things together. There's even online PDF documents that will really give you step-by-step instructions of how to put things together. So, onto what our robot looked like, well, the starter robot looked like for this last season. I've just got a quick video here showing you sort of what it's capable of and what it is.
Hey everybody, it's Greg from Rev, and it is kickoff time again. This is our favorite part of the year where we've learned all about the brand new game center stage, and I know that you are probably just as excited to get going and start building with your team as anybody else. I'm here today to talk to you about our StarterBot program. And the StarterBot is something that Rev has been doing for several seasons now, and its purpose is to give you a place to jumpstart. Whether you are a brand new rookie team joining the FTC family, or you're a seasoned veteran who's just trying to figure out how to get started, what we do is we put together a robot, and this is it, and this robot is designed to play this brand new game. Now, it is not a complete solution. This is not a robot that will take you to winning the world championship. The idea is to sometimes get your mind moving with a very basic solution, so then you can learn and you can start with this and improve upon it over the season.
Yeah, so that's a little bit of what the kit is looking like. Let me get back here. So that's a bit of, you could see sort of what the robot's doing, a little bit of the last season's challenge if you didn't notice. And yeah, so this is what the robot is looking like in more of a photo. So you're going to be building something, it's probably going to look very different from this because the new season will be quite different. But it's going to have sort of the basic look of this robot. You can see here that I have put labels dividing it up into different systems, 4 different systems to be precise. And the first one, and one of the most important to get right, is the drivetrain. So this is really the base for your robot. Everything else is built off of it. And in the starter kit and starter instructions, you'll have all you need to build a really, really great base drivetrain. And what that is going to allow it to do is it's going to allow your robot to drive. So you'll be able to turn, move forwards and backwards, and in the programming sessions, you'll learn how to put some basic code together to get that working right. Off of the drivetrain, we've got a tower, and that's being the I would say, support for our robot actually to play this game effectively. It's got some motors on it which allow there to be a pivot point for this arm, and you saw in the video that it was able to swing this arm and the gripper that's attached to it over to be able to place the pixels after they've been collected. So the arm is mainly just a structural point. It's not doing too much other than allowing that gripper to pivot down from its top position to be able to collect the pixels. And then we've got the gripper. Probably, I'd say, this is definitely, probably always my favorite part to work on, just because there's so many different aspects to it that you can improve, that you can work on. And that's really what's going to be gripping those pixels and then also being able to place them on the board. It's really important. So here you can see from some of the instructions, just a broken down piece, just separated and just being the gripper. And one of the reasons why I've divided it up into those different systems is, firstly, it makes it much easier to understand and just visualize the robot. Because looking at something, one big, very complicated thing, it's very hard to understand sometimes, and it's quite overwhelming, for me at least when I started out. So breaking it down makes the very big complicated thing into maybe much like a few more, maybe slightly complicated things, but now you can really start to get into it and actually understand and feel more comfortable with that particular system. That's what we call them. So we've got a drivetrain system, a tower system, an arm system, and a gripper system. So as I said, this is the instructions and all of the parts that you need to make the gripper system. Now further on in this document, which we will make available as a resource when you get started with the starter kit, and once you've received that and the game's been released, you'll see that there's actually many, many more detailed steps of how to put together the even smaller sub-assemblies of this gripper. So you'll put together maybe that shaft that's got the two big gears on it, or even just putting those brackets onto the extrusion, which is that more like silver rectangular shaped piece there. Now, I think for the rest of this session, we're going to be zooming in or focusing on the drivetrain and what really is important about the drivetrain, what sort of systems make up the drivetrain, and just a little bit of detail into some of the more common parts in the drivetrain, and that will be part of the starter kit drivetrain. And I've got another video here just to show you really how much these instructions and like sort of tutorials will like carry you along and just help you to understand and get a really good grasp of the first concepts of the
We are
robot.
building the 90mm single sprocket shaft assembly. For this step, you will need one 15mm spacer, two 3mm spacers, two short through bore bearings, one 10-tooth number 25 sprocket, a shaft collar, a 90mm length of 5mm hex shaft, and a 1.5mm Allen wrench. To get started with the step, you're going to want to take your shaft collar and the hex shaft. Put the shaft collar flush on the end of the hex shaft and tighten it in place. You're going to want to make sure that the shaft collar is flush with the end of the hex shaft for the rest of the piece placement for this subassembly. Next, you're going to want to take your short through bore bearing and slide that onto the shaft. Note the location of the flange relative to the shaft collar. This is going to be important later on during the assembly. After that is done, you're going to want to take a 3mm spacer, followed by your 10-tooth sprocket. Once the 10-tooth sprocket is on, you want to take the 15mm spacer, place that on, followed by another 3mm spacer. Last piece is the remaining short through bore bearing, and you want to slide that on. Also note its orientation is the opposite of the orientation of the previous short through bore bearing. Once it is done, the 90mm single sprocket shaft assembly is complete. You will need to do one.
So there you saw that was a very, very detailed instructions of putting this assembly together. So really that's just more to get you comfortable with putting the parts together, with using them and seeing what they're for. And you saw there's a few different parts there. I won't go into too much detail of what they are because you will find out very fast once you start using them. But really you get an idea of how much there is to guide you through the process of putting together your first parts, that it really doesn't need to be a challenge. It doesn't need to be seen as a big obstacle to get over. Just really, it's not super challenging when you've got the amount of support that is available to you. So, to get into a bit more detail of some of the parts, we've got a lot of parts on the drivetrain, but I think these are some of the more key parts or more interesting parts per se. So, the first one is an omni wheel. Now, an omni wheel is a very interesting wheel. So, I've got some wheels here, but one of them is okay. Sorry about that.
Halfway through showing the omni wheel.
Okay. Can you hear me now? Is it sorted out? Okay. Has it been sorted? Okay, well, I will start again. So with the Omni wheel, one thing that's like really, really special about it versus a normal wheel is the addition of these other additional rollers on it. So a normal wheel would just be all rubber, all black on the edge in this case. And that would give it really great traction just going forwards and backwards. But an Omni wheel necessarily isn't just for traction or for grip, and it's more for mobility. And you know, a normal wheel, if you try and push it to the side, it really does give a lot of resistance, which is why you can push a car forwards and backwards quite easily, but you can't push it to the side, it would just roll over because of that friction. But if you put Omni wheels on your car, you would be able to push it to the side just as easily as pushing it forward, because these rollers allow it to travel just horizontally to the side as well as forwards and backwards with no resistance, which makes turning with an Omni wheel really much easier than turning with a normal wheel, because there's so much less resistance when it's traveling to the side. So that is an Omni wheel. Then we've got channel and extrusion. So channel and extrusion are very similar. They're really the makeup and the structure of your robot, and they're made out of aluminium, so it's mostly very light, and they have a lot of holes on them. So you can mount shaft to that, you can mount other brackets, you can mount other channel. There's so many different places and different orientations that you can mount parts in. So for designing, for the person who's building with it, it's a really great and flexible material to use when you're trying to mount things or put things in different places. There's so many different things that you can do with it. And then we've got motors. So this is what's actually going to make your drivetrain or any other parts of your robot, that's what's going to make it move. So here I've got a motor, and motors are always providing rotational movement, and they are always going to be turning a shaft. So if you see something rotating or moving on the robot, that's probably got a shaft somewhere on it. And you can see I can put that Omni wheel on here, and now when I turn the motor or turn the Omni wheel, that motor is moving as well. Then chains and sprockets. So when we're driving and you are turning one wheel, you often don't want to only power one wheel. Like we all know that a 4x4 car is able to drive and gain a lot more traction and be able to push or pull much harder than just a two-wheel driven car. And that's sort of also what you want with your robot. You want to be able to make use of as many wheels and power as many wheels as you want on your robot, because that gives you faster acceleration, and it's really helpful. So doing that is with chain. So chains and sprockets really do work together. So you've got a sprocket which is interlinking with the chain, and basically it's playing continuous tug of war with the chain. Those little hooks, they are gripping into the chain, and it's basically just pulling it, which then acts on the next sprocket, which also pulls that along, and you get like sort of a ripple effect along a whole series of chains. So that's a very complicated thing of chain. You won't need to be doing that. What you'll be doing is more something like this. So I've got a bit of an assembly of chain here. It's a bit wonky because I don't have another piece of channel on the other side like the drivetrain would normally have. But you can see if I turn this side, this little sprocket is going to be pulling the chain along, and that's going to be turning this sprocket, which is then going to be, since they're on the same axle, turning this sprocket as well, which will then turn my wheel. So you can see here, you can see the chain moving, and as I'm moving the chain, that sprocket is moving the wheel, and everything is turning. So if I put a motor on here, then it would be turning this and this, which means I would be able to power multiple wheels at once and essentially turn my drivetrain or my car into a 6x6 or a 4x4, or really however many wheels I want to drive. So here you can see I've explained to you a bit about the chains and sprockets, sort of how they're moving. But another way to transfer power or rotation, like we've seen can be done with the chain, is with gears. Now, gears are very similar to the sprockets, and they also have little teeth, but instead of meshing with the chain, as in with the sprockets and the chain, they actually mesh directly with each other. So I've got some gears over here, and with the gears, they actually turn in the opposite direction. So if I turn this one the one way, the other gear is turning the other way. And that's just due to the nature of how the teeth are connecting in the middle, and the one tooth is pushing the other tooth up, and since it's rotating, basically when this one's pushing it up, this one's also traveling up. And because they're on opposite sides of the gear, that's making it go in the opposite direction. Whereas you can see the chain over here, if I turn this one the one way, I'll show you here with this wheel, if I turn the one way, the other one turns the same direction. So you can see that using chain for a drivetrain is much more effective than using gears, because when you want all your wheels to travel in the same direction, chain does that for you already. Whereas with gears, you would have to have different setups of gears to get them to travel the same direction. And also, if I get more gears even, and I try make the distance that the gears are covering further, let me change, then we start getting a really, really big and very wide assembly here, which is much bigger than our little chain thing, which is actually quite narrow. So, some other things. When you are building the drivetrain, as you can see with the instructions here, you can attach the extrusion, like this piece, or the channel with screws and bolts and nuts as well. And you've probably heard of those. And shafts, however, cannot be easily attached with screws and bolts and those kinds of things. So they sort of have their own special way to attach things. And I think you heard in that video, if you still remember, those shaft collars. So they have a little hole in them that allows them to be slid over a shaft. and then also have a little screw that you can tighten that really grips tight on the shaft. And one of the reasons why that is important is because when you put something on a shaft, you don't really want it to come off of the shaft. So if you have something on the end that's stopping it from sliding off, then it's not going to come off the shaft. And then additionally, you can also put them on the shaft at different points to stop things from sliding around when you don't want them to move, which is very important when you're wanting to build a reliable drivetrain, and also when you're wanting it to drive straight and how you're expecting. So here, after you've followed those instructions, this is a photo just right out of some of those instructions for one of the later steps. You can see the motor and the chain and all of that. This is sort of a top-down view of what the drivetrain might look like once you've finished. And you can see all our different wheels, the motors as well. Now, one question is, well, how would we want to move this, and how would we move this in the way that we want it to go? Just in terms of
You need to show
how
the
many...
slides. You haven't been showing.
Oh, have I not been showing my slides? My bad. Okay. So, with I was talking about shaft collars, but I wasn't showing the shaft collars. But we've got the drivetrain there, as I was saying, with the instructions. And with shaft collars, you can see them over there. They've got the hole and a screw, which you're tightening to sort of stop them from sliding about. And that keeps the things that you want on the shaft, it keeps them on the shaft, and it also stops them from sliding around when you don't want them to move. And I said that helps with just getting your drivetrain to do what you would expect it to do, and to not fall apart, which is definitely not desirable. So here you can see what the drivetrain would look like after you've put together the instructions. This is just a top-down view, so that you're able to see all of the different wheels. So with the drivetrain, its main purpose is to move the robot around. And with your car, or with a car, you can move forwards and backwards, and you can turn. So that is with only driving the wheels in one direction, forwards or backwards in one plane of motion. And then you're sort of, with a normal car, you're changing the angle of those front wheels to be able to turn. But with a drivetrain like this, we're not changing which way the front wheels are facing or the back wheels are facing. So how do we get it to do anything other than drive forward or backwards? And this is driving more like a tank, which is why we call it a tank drivetrain. So to drive forward, as you would expect, if we turn all of those wheels forward, then we will drive forward. So I've put a green arrow in this case to show the overall direction of the robot that is traveling in, and then the gray arrows on each side are showing which direction each side of wheel are turning. So if we wanted to drive forward, we just make all of those wheels drive forward. Then secondly, if we want to drive backwards, well, that's quite simple. It would just be the reverse. And we would turn all of the wheels backwards and the robot would move backwards. Now that is very, very basic movement, and you can't really get anywhere by doing that. So we really need to be able to change which way our robot is facing. And with a tank drive, or with this kind of drivetrain, we actually need to turn the wheels in opposite directions, which might be a bit odd or seem a bit odd, but if you think about it, when I move something forwards, so let's say I just keep the right side of my drivetrain still, that would mean that the front of the drivetrain would be moving forwards, but the left side of the drivetrain would be moving forwards, but the right side would be completely stationary. And that means because it can't just detach from the drivetrain and carry on going forwards, it would need to sort of make a pivot point around the right side, and it would sort of go in an arc. But now if we also make the right side turn in the opposite direction, that pivot point gets shifted right into the center of the robot. So we end up doing a turn that is exactly on the center of the robot. And that is very important for the first tech challenge where there's a lot of robots on the field, there's not much space, so you really want to be efficient in your movements. You can go forwards and backwards, and you can turn on the exact spot. And then, as you would somewhat expect, if we were to turn the other direction, we would need to change the direction our wheels are turning. So on the right side, we would need to turn forwards, and on the left side, we would need to turn them backwards. And that would give us a left turn. So now I think you can see really sort of the basic ways you would move the drivetrain forwards, you would turn it. And I hope that's a really good cover of sort of really the drivetrain and some of the other systems in the robot. Here's just a summary of that. So you can see moving forwards and backwards and turning left and right, which directions those wheels need to turn and why it makes the robot move in those different directions. So that is me finished. Well, me finished in terms of what I've planned to present. There's a lot of space for questions. I know I've covered quite a lot of different things in a bit of detail. But if you have any questions for clarifying anything that maybe was a bit confusing, or something that I haven't covered that you would also like to hear about, that's related to this kind of content, if you could ask a question in the stream chat, preferably with your name as well, that just does make things easier for us. That would be awesome, and I'll be trying to answer as many of them as I can. So you can fire away. I'll be looking out for your questions. So I see one question. Can this type of drivetrain effectively move in any direction? So this type of drivetrain, it can in some ways, but it can move in any direction, but you will have to change the heading of the robot, which is sort of where it's facing. So you can see here, these are all of the different ways you can move. So you can move forwards and backwards, and then you can turn left and right as well on the spot, which means essentially from any one stationary point of the robot, you would be able to move in any direction, but you would have to change which direction you're facing. There are other types of drivetrains that can be used in First Tech Challenge, which do allow you to move in any direction without changing where you're facing, but those are quite a bit more complicated, and I mean, you can get those in your first season, but it's a bit more challenging to understand and to put together than something like this, which is why we think that the starter kit and the starter drivetrain are such a great place to get familiar and understand just the base concepts before you tackle something that's much more challenging. Another question. Why are the black wheels driven in the picture? Is it good to drive the Omni wheels? So really, when driving the wheels, it doesn't matter so much which ones you're driving in this case. So normally there are different ways to build an Omni wheel drivetrain. This is one of the versions with an Omni wheel drivetrain. And in this drivetrain, the Omni wheels don't provide a massive benefit using Omni wheels. But in some other types of drivetrains where, for example, you don't have the middle set of wheels and you're only driving the non-Omni wheels, then they do provide a massive difference. But in something like this, they don't provide as much of their unique characteristics. They don't contribute as much to the drivetrain. And driving them in this case, it gives you more wheels driven that are contacting the ground, so you'll have more pushing power, more acceleration than if you didn't drive them. So in this case, it is really good. And tensioning a chain. So that's another thing. I will show you over here on my picture, well, on my video. I have got a chain set up, as I've shown you before. And I've got a chain here. And you can see that maybe it's a little bit loose in this one part. So you can see I've got excess chain here. And that is what this other shaft is doing. So if I didn't have this, these two pieces of chain, we might have skipping over here, which is basically when I turn this sprocket and one, or like to move one link around, but it doesn't move one link on this side because it just, the sprocket moved without the chain moving. And that's one of the disadvantages of chain and having it not tensioned. So having this little roller over here, which can spin around quite freely, it does have a bit of friction, but it's good enough for the chain because it's plastic on the metal and it slides pretty nicely. That's a really great way to tension the chain. Of course, you could have like another sprocket on this as well, and that would be even better, but this works for most cases. And I can show you again on the presentation here, a little bit further back. You can see that over in these places, they're also using very similar methods to make sure that chain is tensioned. And I have found very personally that tensioning chain can be a little bit annoying, just because putting together the chain, it doesn't always give you the right length. Then another question, do you or can you use the same parts every season? Do parts wear out quickly? And can you add other parts? So, we have had the same control hub. So the control hub in the beginning is sort of like the brain of the robot. We have used that for 4 seasons. So, and we're still using it now even. So it's lasted a long time. And these gears as well, if I show you, these gears also 4 years old. This one, 4 years old. The motor's 4 years old. They all still work perfectly fine. Now, they aren't the highest of wear parts, like our chain is like slightly rusted. It doesn't have, well, it's not really that rusted, but it doesn't have its lubrication oil on it anymore. So, I mean, it's starting to wear out. But really, they last so long. These are very thick, high quality parts. Same with this extrusion, like it's got a little bit of a beating. You can see there, it's got some marks on it. But really, as long as you don't do things that you would like, I mean, you haven't maybe dealt with many of these parts, but if you don't go hitting this on another piece of extrusion really hard or whacking it with a hammer, it's probably not going to break particularly quickly. Then, yeah, you can of course add other parts. So we have added many different things, including things that you can't even buy in an FTC kit. Like I'll talk about it in a future session, but we use ice cream tub and like cardboard. On our first robot, we made like the robot look nice by just putting like cardboard box on the side and painting it and sticking things on it. So you can add almost anything you want. You can even sometimes use different motors that aren't only made by one supplier. So there's lots of different things that you can add. And yeah, it's almost limitless in what you can get. So, do you have recommended YouTubers for us to watch and learn, or other sources? Yes, there are quite a few. Sometimes it is a bit specific to the challenge that you're dealing with. There aren't many. I wouldn't say there's like a specific YouTube channel that covers like everything, but there's different teams that have a YouTube channel that'll give like a course or some information on a particular topic or a particular issue that teams are having, as well as like you can ask questions on the Discord server if you are struggling with something, or maybe need a particular resource for some aspect, and then we'll be able to supply that to you. But I think with the instructions and sort of the starter kit build guides and videos, I think we'll send those out when you receive a kit or when you've got a kit, then you'll sort of have all you need to understand those different videos, because maybe if you're watching it, you're like, oh, what is that part? I don't have it. I don't know how to use it. And then you might forget after watching the videos. But I think, yeah, that's a great question. We can definitely get you those resources. And then, when is the software training session? So that is actually happening tomorrow at 7 p.m. So that's also going to be very similar. Our programming lead from TechSpan, I think, will be presenting. So he's got quite a lot of experience, and he'll probably be able to answer your questions there and give you some basics on the side of programming. Also, another thing to do with watching the like YouTubers or different instructions, I would highly recommend watching past matches from different seasons. I think it's a really, really great way to get perspective on what's possible with FTC, what kinds of robots you can build, how different people solve different problems in different ways. Because like you go to a competition and there's someone who's got maybe linear slides, like whatever, to like draw slides to lift something up. You've got another team that has a pivot, like in this robot that we saw. So there's so many different ways that different teams solve the same problem. And it's really great to see how they do it, how well it works, and what they've used to build that particular system or solve the problem in that way. So I personally find it really entertaining as someone who has like actually done this kind of robotics before. It's really amazing to see how different people approach the same kind of thing that I'm doing. And I think it would be great for you guys who maybe haven't even seen the competition, just so that you have an idea, or you go into the season seeing, wow, this is what I could be able to do in a year and a half, or in 2 years, or in my second season. Just having some team to look up to and see like, wow, I would like to be make a robot as great as that one day. And I think it might give you a bit of a head start in seeing, wow, this is what I've got now. This is how they solved a similar problem. This is how they made a really great gripper. And then you could see like, oh, okay, well, they did this to improve it. I could also add that to my gripper. And that might help you in the second stage of the season, where after the scrimmage, after the practice competition, you're looking for a system to improve. And yeah, I think, okay, one YouTube channel that would be very great to watch, or a series of videos, is called Behind the Bot, by a channel called First Updates Now. And they basically take a really great team's robot and they really break it down and say, okay, this is how you solve this problem in this season. This is how you solve this problem in the season. And it goes into hardware and software side of things. So once you've got like a basic understanding, you've watched some of the games, you've seen a few of the basics of how their robot operates and performs in a game, then going and watching a behind the bot of that robot is like a really great deep dive into how they've done different things. And I think even like, even if you're not going to be doing the same challenge, there's so much you can learn from past seasons games and the ways other people have solved similar problems. You don't know, maybe there's going to be like you're going to be gripping different shapes like of elements this next season, and someone's gripper from this last center stage season is almost exactly what you need. And just because of watching that video, watching the behind the bot, you now know, okay, well, this is exactly how I can modify my system to, or my gripper to very effectively grip this piece. Then another question, what is the connection between your hardware and what your software needs to do? I think Josh will get into that a little bit, but what you're doing, sort of how you program or how you go about things when you're just starting out, is you build the hardware and you're like, okay, this is what I've got. And then you sort of thinking, okay, I've built this system. What was it built to do, or what can it do? And then in the software side of things, you'll set up and sort of make it do or achieve those goals that you've set out for it on the mechanical side. So with the starter kit, a lot of that is done for you already, and there's also guides on how to program it. So that can be helpful. And if you get stuck, as always, you can really just send us a message on or an email, send us a message on Discord, on the Discord server, or email us, and we'll happily answer your question with regards to software and how you set up those two. Then, another one. What are the basic tools we need to build the first robot? Do they come in the Rev kit? What other tools could be useful? So, you will definitely get the basic tools needed in the Rev kit, and there are a couple of others that we would recommend. So, if you can see here, there's sort of these, I don't know how clearly, but there are these nuts, and they're sort of hexagonal shaped, and you will get a screwdriver or a specialized socket wrench thing to be able to tighten and loosen those as need be. And you will also get different sized Allen keys, so that, let me get an example. Yeah, so you can see here on this motor, there's that screw over there, and that's actually got an Allen key shape in it. And you'll get those sized Allen keys with your kit as well. But some other tools that we would recommend getting is some duct tape and some cable ties. You'll get some cable ties in the kit, but it's really great for maybe you've got cables and they are not going where you want them to go. Get some cable ties, get some duct tape, strap it to a piece of extrusion or a bracket, and that'll keep them out of the way very effectively. Another tool is super glue. I don't know how effective that might be with the starter kit, since everything is planned out, and it should work mostly as the instructions say. There might be a few problems here and there, but super glue if something breaks, or maybe you want to very permanently attach some cardboard together and then attach it to your robot, or to some bracket, then super glue is a really great way of doing that as well. And then if you're using other parts that aren't from the Rev kit, maybe some other screws, or maybe you've used some wood, then having a screwdriver on hand it wouldn't hurt. And a pair of pliers as well. Sometimes to orient, I'll go into more detail in that in future sessions, but when you're slotting parts into the channel here, sometimes the heads of the screws are not very cooperative and they don't want to go in the slot. And having a pair of pliers to just like slightly reorient the screw, or maybe even like pull it out if it's gotten stuck somewhere, that's also like incredibly useful. And also like sometimes they're very small and the screws are very small or the nuts are very small and you can't hold them with your fingers and get them down into a particular location. Then having either like a magnetized screwdriver to like sort of lower it into the right place like a crane, or using the pliers for that, that's also like saved so much time for me. I think that is all questions. Yeah, so there is one thing left that can be done. Let me go back to my presentation, and I have made a little bit of an assignment for you guys. So there are some questions that I've put together on a Google Forms document that you should mostly be able to answer. I think I've got like 5 or 6 of them, so it's really not much. But if you would be able to take some time to go and answer them, you should be able to answer them. Mostly, I think I've maybe put in 1 or 2. I think I've put in 1 that you might have to do a little bit of research for. But you should be able to answer most of the questions with regards to what I've covered in this session. So I will send the link on the Discord. So if you are attending this session, then I would recommend checking out the Discord for that link. I'll send it on very soon, just straight after this. And you can practice and get some recall in to make it stick in your brain after hearing so much information here. But that is all for me. And we will be covering some more detail on gears, the weird and wonderful things, and also a little bit more of a deep dive into some grippers and other servos as well, and the other systems and different ways of powering them. So I hope you're looking forward to that, and that's all.